Alright, today we're covering 8.1 to 8.3 word problems. My first suggestion is always draw a picture first. So if they don't give you a picture, you need to draw a picture. The second thing you're going to do is determine what trig you're going to use. You're going to use basic trig, which is the SO, CA, or TOA, so sine, cosine, or tangent, if you have one right triangle in your picture, or if your right triangle has a known side. Okay, and we'll see an example of where you wouldn't be able to use basic trig on a right triangle. Okay, law of sines you're going to use if you have an angle and the side across, or if you can manipulate your triangle so that you have the angle and the side across. Okay, remember, law of sines is sine of A over little a equals sine of big B over little b equals sine of big C over little c, and you choose two of these fractions to use. Law of cosines is going to occur when you have an angle and two sides, okay, where your angle is not across from the side, or if you're given all three sides. Okay, so for example, if you had this, 40, 5, and 6, you would use law of cosines because you don't have the side across, and you would use it in this case because you have all three sides. Law of sines you use when you have the 40, the side across, and then another side. Okay, and then your last step is to solve the equation that you used. So here's our first example. You have a straight trail leading from a hotel. So here's my hotel. Okay, and your hotel is at 8,000 feet. Okay, and then there's a trail going to a scenic overlook that's at 1,100 feet. So the first thing you have to recognize is you need to subtract these two numbers, because we know then that it went up 3,100 feet. Then it says the length of the trail is 14,100 feet. What is the inclination, which is the grade of the trail? Okay. So what we're looking for is this angle here. Okay. And then this, I didn't give you the picture, so, because I wanted to draw it. So if you look at this, you should notice we have one right triangle. And so we are going to use regular sine, cosine, tangent. In this one triangle, we have opposite and hypotenuse. Okay, that's based off of this angle. So if I look at SO, CA, TOA, I have opposite, hypotenuse, means I'm using sine. So I would do sine of my angle equals my opposite over my hypotenuse, and then I would sine inverse each side to get my angle. So my angle is going to equal, let's bring up the calculator. I would do sine inverse of 3,100 divided by 1,4,100. So my angle is 12.7 degrees. Now, if you don't get 12.7, the common issue is that you're not in the right mode. So in this case, we're talking about degrees. So we want to be in degree mode right here, not in radian. Okay, so if you get a different number than 12.7, it's probably because you're in radian mode. Okay? All right. So that's the answer to that one. So on to the next. It says, to measure the height of a mountain, a surveyor takes two sightings of the peak at a distant 900 feet apart on a direct line to the mountain. See figure 31A. So that's this picture down here. Okay. The first observation results in an angle of elevation of 47 degrees and an angle of 35 degrees. Okay. The transit is 2 meters high. So what this is telling us is that after we find our h, we have to add 2 to it to get the actual height of the mountain. So, in this picture, we do have a right angle. But what you need to notice is that we don't know any of the sides of that triangle. Okay? And so what that tells us then is we're actually going to use these two. So if you ever get a right triangle and you don't know a side, you're going to use law of sines or law of cosines. So I'm going to use law of sines on this picture. Okay? And so usually when you have this kind of picture going on, you're going to use law of sines. And so the first thing I know is this is 133 degrees. Okay, and I'm just trying to manipulate this picture so that I have information that I need. And then I also know, because I have these two angles, okay, that I can do 180 minus 133 minus 35. And now I know that this angle is 12 degrees. Okay, because that's 168. 180 minus 168 is 12. And now I have an angle in the side of cross, so I'm going to use law of sines. So I have sine of 12 over 900 equals, and I'm going to do sine of 35 over x, which is going to get me this. And then once I have that number, I can use regular trig to find my h. And so I get x sine of 12 equals 900 times sine of 35. So I would do 900 sine of 35 on my calculator. Gets me this number, and then you're dividing by whatever sine of 12 is. Notice how I'm using as much buttons as possible. I'm not plugging in sine of 12 and dividing by that number. I'm just doing answer divided by sine of 12. Use your calculator as much as possible. Do not write down decimals if you don't have to. And so then what this gives us is that this length here is 2,482.875 for this length here. Okay, so this length here is this number. So now that I have that, and that I know this is 47, I can use regular trig to find my h. So again, this is opposite and hypotenuse. So I'm going to do sine of 47 equals my opposite side over my hypotenuse, which is the 2,482.875. And now this is going to let me find this distance, okay? And then I'll add that 2 to it once I know that. So I'm going to cross multiply this times sine of 47. Okay, again, using as much buttons possible. So I have this, so I would just type second answer times sine of 47. Enter. Gives me 1,815.9. 1,815.9, and then I have to add 2 to it. So 1,817.9 meters is going to be the height of my mountain. Next, we have Coast Guard Station Zulu is located 120 miles due west, okay, of Station X-ray. A ship sends an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is north 40. Okay, so you go north, and then you go 40 degrees east. The call to Station X-ray indicates the bearing from the ship is north 30, north, and then 30 west. Okay, how far is each station from the ship? Okay, so we want to find A and B here. What you need to notice is that we have 50, 60, and 120. Okay, but we can subtract these from 180 so that we can use law of sines. So I would do 180 minus 50 minus 60, which is 70 degrees. So C is 70. So now I can use law of sines. So I have sine of 70 over 120 equals, let's do B first. I'm going to do sine of 60 over B. Again, when you plug this in your calculator, do as much as possible using it. So I'm going to do 120 times sine of 60. And this is B sine of 70 equals 120 sine of 60. So 120 sine of 60, which gives me that. And I have to divide that by sine of 70, which gives me 110.6. So B is 110.6. 110.6. So now I'm going to do the same thing for A, but I'm going to have sine of 70 over 120 equals sine of 50 over A. So A sine of 70 equals 120 sine of 50. So now I'm going to go to my calculator. 120 sine of 50 gives me this number. And then I would divide that by sine of 70. 97.8 is the length of A. So this is 97.8. So that's my answers to the first part, part A. Then it says, if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take it to reach the ship? Okay, so we're going to find this in hours, and we're also going to find it in minutes. Okay, so it's 200 miles per hour, and we are 97.8 miles away. Okay, so you would do 97.8 divided by 200. When you divide that, you get 0.4 something. Oh, and look, I have this number plugged in from before, so I'm just going to use that answer. I get 0.489. Okay, so that's hours. Now, typically, when we have a weird hours like that, we're going to times this by 60 so that we know how many minutes that is. So times by 60. So 29.3 minutes is how long that will take. Okay? And our last one. So we've used law of sines here twice. We've used regular. So I hope you know we're probably going to use law of cosines here. So it says a motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour. But entering heavy crosswinds and strong currents, the crew finds, after 4 hours, that the sailboat is off course by 20 degrees. So then what they did is they did 15 times 4, which means that they have gone 60 miles off course by this 20 degrees. Okay, so it says, how far is the sailboat from Key West at this time? So I'm going to let this side be my C, okay? And I'm going to do law of cosines. So I'm going to do C squared equals A squared, which I'm going to let be 150, plus B squared, which I'm going to let be 60, minus 2 times 120 times 60 cosine of 20 degrees. Okay, so then I get C squared equals, and I would plug this directly into my calculator. So I get 150 squared plus 60 squared minus 2 times 1. Oh, this should be 150. It's a misprint. 150. So 2 times 150 times 60 cosine of 20 gives me this number. So C squared is 9,185.5. And then you'd square root each side to get C. Is 95.8. So C is 95.8. Okay, so that's the answer to part A, is this. B, through what angle should the sailboat turn to correct its course? Okay, so what we're looking for is, okay, it's driving straight. What should it turn, this theta here, so that it's on the right course? Okay, so I'm going to do sine of angle A over 150 equals sine of 20 over 95.8 degrees. Okay, now when I find this A, there's something called the hinge theorem. And so when I find this A, it might actually find me this outside angle. So be aware if it doesn't look accurate, it's probably because it found the wrong angle. And so we're going to do 150 sine of 20, which gets me this number. Okay, and then we have to divide that by 95.8, which gets me this. And then I'm going to sine inverse that answer. Yeah, I did. So this is 32.4 degrees. So out here is 32.4, which is actually how much we would have to turn our ship to get going the right direction. Okay, if you wanted to figure out this number, you would just subtract this from 180. Okay, and then part C, how much time has been added to the trip because of this? Assume that the speed remains 15 miles per hour. Okay, so we know that it went from 150, which if you're going 15 miles per hour, it means it would take you 10 hours normally. Okay, instead, you go 155.8 miles, divided by 15 is going to tell us how many hours that is going to take. So 155.8 divided by 15, 10.4. Okay, now that's hours. So if we subtract 10 times by 60, they just added 23 minutes to their trip. Okay, which isn't, I mean, that's not horrible, but could be better, right? All right, and so your assignment's actually over here, page 517. There's 4 problems on each page, and I will do one from each page tomorrow before your test.